Hello and welcome back. In this video, we'll be looking at the web-based example for SQLi injection. Okay, so you should be able to access this website. This website is available from public. It's built specifically for you to just try a few different SQLi variants as well. Okay, so once you can access it, here we go. So here I can see that. Okay, you should be able to log in as well. Okay, so let's get started. Okay, test to see if it is if it will be vulnerable to SQLi. So as seen in the example, we have seen the address up here is likely be passing into the database as a query, which means we can add some additional items in there. Okay, so all we do is add in this percentage 27. Okay, so let's do that. Percentage 27. Okay. Yeah. So if you try percentage 27 and enter, you should be able to see something like this, which is like what we have here. Okay, and basically 27 is a single quote, and we're trying to induce some errors out of this database. So we can get some information out of this. This is using MySQL, so the comment is going to be the double dash and a few different info out of that. So just knowing the MySQL and be able to craft our query fit for that is already a good start. Okay, so next item is we probably want to know, okay, how many tables there may be. Okay, so this way to identify that, we can use the order by command. So all we can do is insert order by and then start from 1 and then keep going up until it throws an error. Okay, what it does is check how many columns there are. Okay, and it will throw an error if you don't have enough columns to check that. So here order percentage 20 is space by 1, and we get our normal things back. Okay, instead maybe try 2. Okay, it's going to do the same, and eventually you try 3 and we try 4, and this is gonna give us an error. Okay, so that means the point you get an error is where it fails to match that many columns. Therefore, the one that you just tried before, in this case, is 3, meaning our table we have 3 columns. Okay, so now let's try to discover some other stuff in the table. What we can do is throw in a command like that up there. So instead of now order by, we're going to use a union based attack. So union, copy this. Union select 1, 2, and 3. Okay, and sorry, -1, not just 1. So we want to mismatch the article to understand more about what gets put into place. Okay, so we went union -1 union select. So here we have artist 2, 3, and so forth. So here artist 2 and 3. Okay, so what this allows us to do is now we can put other schema into fields 2 and 3. Okay, essentially what this command did was 1 in the place of 1, it put artist. In place of 2, it displayed 2 directly and 3. So this means we can probably map out some of the other schema details into fields 2 and 3. So let's find out the database name. Okay, this can be done by calling a database variable name. So instead of now 2, we add database function and enter. Then it's going to update our second field with the database name. So the database name for this guy is ACUArt. Okay, the database name. And then we found the database name is ACUArt. Okay. And basically, from this point, you can start recovering some of the information about the database, the schema, what the contents is like, and so forth. Okay, so here we can discover things like version, user, table names, other table fields, etc. And eventually we can get some sensitive info stored in those. So for example, we can run something like this. What this is doing is we're checking username here, and here also we're checking password. Okay, and basically we discovered that there is a username and password set that contains test and test. So somebody forgot to change this. Okay, so maybe you can try something similar for username root, and maybe there's a password associated with the root that you will be able to return. Okay, and yeah, I will leave you to explore that. You can explore some other SQL attacks and test it on this public website. Yeah, so as you can see, SQL databases, they provide really good means to manage large amounts of data and how we can map our relationship between different fields. But there are some downfalls where people can inject a lot of different types of malicious statements that can cause issues and leak sensitive information. Okay, so there are additional prevention methods, things like prepared statements. This is supported in the JDBC and other database application interface. So it's kind of like a standard that you can use. Basically, what it does is all the SQL query is pre-compiled with placeholders. And what it do is basically when somebody injects something, it's going to interpret it as a user input statement string. Okay, rather than interpreting that as a command, it's going to interpret that as just the input string. Okay, basically, when you had an attack something like this, before it chopped here at ASDF and interpreted that as the input, and then interpret OR as a command, and then we had another input and command in mixture. But using prepared statements, what it's going to do is match exact string of whatever has been inputted with the contents. Okay, so it's not going to interpret these as commands anymore. It's just going to be interpreted as input. Okay, so this is all good and all, but prepared statements have some issues. Generally, it cannot be used in all situations. For instance, it's very good for used with select, insert, update, delete statements, but in SQL queries we have a lot more other options that we could do, like where and schema and tables, etc. Okay. So for example, if we also ask the user for information that determines the choice of the table name, then we are asking users for some commands to be inputted as part of the query. Okay, then we cannot use the prepared statement for these types of fields. Okay, then that means attackers can exploit these specific fields that are not filtered out in the prepared statements. Okay. In addition to that, we have some additional precautions. Do not access the database as a privileged user. So that means if you access the database as a privileged user and somebody finds a SQLi vulnerability, then they will have the same privilege, which means they'll be able to insert, modify, delete all the entries as well as whatever you are allowed to do in the database. Okay, you want to limit the database user to only what they need to do. Okay, this is going into like a role-based access control, but we don't actually touch it, but you should be aware of. You won't be assessed on that. do not allow direct access to database from the internet. So basically, our web example was that you can interact directly from the internet, so that's not a good thing. You could possibly require users to go through your applications, like this application that we had before, which does some pre-filtering. Do not embed database account passwords in your code. So sometimes a lot of people just leave their test account details in the source code, whether it be like the applications that we saw or even the web applications. Sometimes you can inspect the source to find some more details about it. Okay, and do not expose information in error messages. So something like this, where it's really exposing a lot of information, like, okay, this guy has this table name user details and has two columns called username and upass. Okay, we have some catalog, we have the address, and the source is located in this particular line. So this gives out a lot of information about the details where the attackers can utilize. Maybe I can find some other vulnerabilities. For example, I can maybe SSH into that and find some vulnerabilities there, or do some cross-site scripting, which we'll see later, or do some man-in-the-middle attack, denial of service, and so forth. Okay, so there's a lot of things I can do if I find this information out. Anyway, so that's all the details for this video. Yeah, otherwise I'll see you in the next one. Bye.